Polaris should be available for you guys. So this is the problem. We have the media server that typically go through the internet channels. Okay, there are many people accessing this media server. Okay, they might have very high-speed ADSL line. Okay, like your regular desktop setup. They can probably not a lot of people doing 56K modem anymore, but still there might be some. There are people accessing it from their wireless cell phones, for example, or their PDAs. Obviously, we have to worry about compression, scalability, error resiliency, low latency. So all these things has to come into play. Okay? Now, so we understand all these already, so let me skip. Okay? Now, typically, the architecture for media streaming is shown here. You have the streaming server, which is where Akamai sits, where Real Networks and Windows Media sits. Okay, and it has raw video coming in, raw audio coming in. It has a storage device with the encoder built in, so it will do encoding, store it in the servers. It has application layer quality control stuff over here. Transport protocol, like the one that we talk about, packetizations and headers, information. So it has all these. Okay. The output is going through the internet wireless IP networks with internet protocol. At the receiver, you have the transport decoder, and then you have the application layer QS control, which might do concealments and all these error detection correction stuff. Okay, and then it has the video decoder, audio decoder right here with synchronization and playback. Okay, so we talked about video components already. So maybe the most important things in here is the application layer quality control, because that's where. So we're very familiar with all this. Okay, we know what this is doing. We know what this is doing. So the rest is just good. Okay. Now, so in streaming, media stored at the source, right here, it will be transmitted to the client through all these nodes. Okay, and the client play out, which begins before all the data has arrived. So the key word here is before. Okay, this is where the difference between streaming and downloading. In downloading, you hit the download button, you wait until everything gets to your desktop, and then you play. Well, okay, then you just wait, okay? And there's no challenge there. Okay, the challenge is the client starts to play before the data are dry. So what it means is maybe there's a buffer at the beginning, okay, and the key is to reduce the buffer, right? Reduce the wait time. And ideally, you would like for the client to play immediately when they hit the play button. But most of the time, that's not achievable because we don't have the communication bit rate. There's a lot of latency out of these nodes, okay. And now, one of the so you have the this is the cumulative data right here, and this data with respect to time. And as you can see, the data, okay, the draw data coming in being compressed, okay? And these are the size of the video that start to go up, okay? So the size keep on growing, the size of your entire video that you are about to send. For downloading, we're going to wait until the video is completely compressed, and then we're going to hit the send button, and then you're going to wait until all the things get here, and then you play. Okay? But for streaming, what happens is you send the video like this, but then you start to play. See, you start to play right here, where all the data hasn't gotten there yet. Okay? And this is called the network delay. Okay? This is the delay between you hit the play button and the actual play out start to the first frame start to appear on your computer monitor. Okay, so the goal is to reduce that. Okay, So at this time, the client play out early part of video while the server is still sending later parts of the video. That's the entire difference between. Okay, so let's try to take a look at the delay jitter behavior. Okay, cumulative data is here, constant bit rate transmission. So let's make some reasonable assumptions. Okay, so with constant bit rate, you can see that all the stairs is very regular. Okay, so you can think of it as this is 1 frame, this is 2 frames, this is 3 frames, 4 frames, 5 frames, 6 frames, so on and so forth. You use exactly the same amount of bits for every single frame, and that will lead to constant bitrate application. Okay? Now, in a lot of the video that people stream over the web, like news and movies, okay, then you don't have this nice behavior. You're gonna have this staircase. Okay, iframe take a lot of bits and then and take a long time to encode. Okay, and then P, so on and so forth. Okay, so you have an irregular staircase, and what leads to a variable network delay. So sometimes a frame has more delay than the others. Okay, because of the bandwidth it takes, because of the bad routes that it chooses, so on and so forth. Okay, so so you have to work out the buffer such that at the client you still want this regular player, right? You don't want a jitter type of player. You want a regular player. Okay, 1 frame, 2nd frame, 3rd frame. Okay, so your job is to smooth out this type of transmission or streaming, so that at the playout is also constant bit rate and nice. So let's see, streaming multimedia interactivity, meaning that not only you can stream, but you can pause, you can rewind, you can fast forward, you can push a slider bar, so on and so forth. So this is the advanced case of streaming. Okay, so it works just like your VCR. You can do a lot of things with it. Okay, you can so 10-second initial delay is okay. 1-2 second delay until the command take effect seems to be okay. I'm willing to live with this, right? So, but that's the goal. Okay, how do we actually do this so that we can achieve a very minimum initial delay, and it doesn't take a long time between the time where I hit rewind and fast forward to take an effect. Okay, so when you hit something, the server has to respond, and you want the server to be very responsive, very, very quick. Okay, so I don't have much more time. Let me try to skip forward. So maybe let's just spend a little bit of time talking about the challenge. Okay. Certainly bandwidth is important. Okay. The bandwidth of the internet is time varying, so we have to take that into account. You need the rate control algorithm to match the channel rate. That is the key problem of streaming. So if you want the playout to be regular, if you want the playout to be regular, you have to be able to match the rate control of your algorithms so that the video bit rate match exactly the channel behavior. Okay, the effective channel behavior, meaning that not only the bandwidth that it allows you to do, but it's also how much error your channel has, the effective bandwidth. Okay, because all of that we have to be able to determine in real time how to control the rate of our compression so that it matches channel. Second, we have to minimize the end-to-end. You have to be able to control your buffer in a nice way so that it's not so large and it doesn't lead to an outrageous amount of delay. You have to minimize transmission loss. The compressed bit stream is very sensitive, okay? So you need smart error control to recover from the loss. So now the loss of streaming can come, the extreme, the most popular type of loss that you see in streaming would be you do not have enough buffer. So your buffer plays out is at the end already, while the new data hasn't come in yet. Okay, so that is one of the major challenges of streaming media nowadays.